Alright, so off we go with 3, 5, and 6. It says quiz, but we're doing practice quiz. Problem number 1 has tan on it. If our sheets match, is everybody matching me that your sheet said tan?
Yep.
Because I've got a few of these. Just make sure we have the right one. So how's the chain rule work? You work from where to where?
Outside in.
From outside in. And all of the pieces in the answer when we're done should be doing what to each other?
Multiply.
Multiplying is correct. So number 1, if we start on the outside, we're looking at
Secant squared.
making secant squared. So we see tan. We need to still remember our trig derivatives. The derivative of tan is secant squared. So secant squared, and then in parentheses should be
3x squared plus 9.
the exact same 3x squared plus 9 we started with. If you get to the end of the problem and you have parentheses that like disappeared, something wrong has happened. So most of the answer is secant squared followed by the same set of parentheses, but who else is in this?
6x.
A 6x. So grand total 1 would be 6x, secant squared, same stuff. 2, where are we looking for 2?
Put the 10 power to the front.
10 to the front, the power's now to the
Ninth.
ninth. And that's most of the answer, would be 10, same parentheses, to the ninth. But then you'd have to make one more set of parentheses because the derivative of the inside will make 15x squared plus 8x. So I went one more step, which is more a question of mood, I think, than correctness. What one more thing could we do there? But I don't know if it was actually helpful. Distribute the 10 into one group or both groups?
Just the second group.
Just the 15 group. So my total answer I did was the original thing in parentheses to the ninth. And then one set of parentheses where I distributed in the 10 and got a 150x squared plus 80x. Do I care if you do that? Right now, I don't feel like I do care if you would distribute that 10. But whenever I made this key, I did care. So that's more of a mood style choice, I think, there. 3 is deceptively written because it looks like cosine is outside when in fact it's inside. The 5 is outside. An alternative way to write 3 would be cosine x in parentheses with the 5th outside. That's a more accurate way to write that. Anybody 3 think you got it?
-5 times cosine x in parentheses to the 4th sine x.
That's fine. -5, a cosine x that's to the 4th, that you could either write your 4 the way I wrote my 5 in the problem, or you could keep the cosine x wrapped up in parentheses and have a 4 outside that. That's fine. But there's also a sine x multiplying into the mix. 4 is the longest one of this page. First you'll have to deal with the 5, then you deal with the sign, then you deal with the parentheses. If you do this and you multiply everything that can be multiplied out front, you're going to get a 60x squared. If you didn't get a 60x squared, look around for a 5 once and then a 12x squared later. It'll have sine to the 4th power with the parentheses that the problem had, and it'll also have a single cosine with the parentheses that the problem had. So grand total 60x squared, sine to the 4th stuff times cosine stuff, where when I say stuff, I mean the parentheses that I wrote when I first authored this quiz, whenever that was.
What was the last thing you said?
60x squared, sine to the 4th stuff, cosine stuff, where stuff, I mean
Yeah.
the parentheses. Anybody, front page, anything?
What was 3?
3 was -5, cosine to the 4th x sine x. I count that front page 2 points apiece, so that's like an 8-point page. If you forget like one little thing, I might take a half. If you forgot 2 things, maybe I take a whole. 3 mistakes and doing 1.5. Total train wreck, you just get nothing, but something front 4. 5, still doing the same thing. So the first thing we're doing is dealing with 8. So we're going to go 8 stuff to the 7th. And then have one more set of parentheses with lots of stuff in it. What's the new stuff in the new set of parentheses?
16x to the third.
Yep.
Plus 15x squared.
Yep.
Plus 12x.
Agreed. And then based on my mood at the time, I then distributed the 8 into that because I could. But I don't actually know if that makes it better, honestly. But I did have an alternate answer, 128x cubed plus 120x squared plus 96x. Maybe another year, another time, I'd have another different mood, but today my mood is that that's not really doing anything to make it better or worse. 6 is going to use your favorite thing. What is product rule? So 6, we got one big mass of stuff multiplying another big mass of stuff. We're going to have to do product rule, and you're going to get 2 big like masses of stuff with a pair in each. And this is the one I told you was coming, where you could do that magic trick that I did, where they're almost like terms. The one original parentheses group on half your product rule is to the 4th. The other original parentheses group in the other half of your product rule is to the 3rd. There is a way to force those into matching and then get it put together. Does anybody have that magic trick pulled your rabbit out of your hat, have that in final form?
X cubed plus 5x squared to the third times 14x4 plus 50x to the third.
It is. And I'd probably leave that hang until tomorrow in terms of the details, once everybody has a chance to see if you can pull that on your own. But yeah, the one group, the one parentheses group is x cubed plus 5x squared, and it's to the 3rd. The other parentheses group in the best possible answer is 14x to the 4th plus 50x cubed. Before that, it's like twice that size. It'd be a big thing of that size plus another big thing of roughly that size that are gonna get like put together. Those are 2 points each again. 5 or 6, anything you want me to follow up on?
How would you start 6?
Product rule. So copy the first exactly as it is, times the derivative of the second, which isn't that big, plus copy the second, times the derivative of the first, which is more like the problems we were doing 1 through 5. That's going to take a chain rule for you to do the derivative of the first. But it's going to be 2 pretty big long pieces separated by a plus. Is that enough to get you going?
Yeah.
Do you have enough to get you going on that? Did you forget product rule? Did you get far into that one?
No.
Okay. Did you mess up the product rule part?
Yeah, I forgot to do it.
Okay. So we'll double back to that problem or something tomorrow, I guess. So we'll end up doing another sheet anyway. Anything I can do up to 6 to help you get moving? 7, we're doing a switch of problem type. If it's not y equals, we're going to switch to the thing that was called implicit differentiation. So the 2x cubed is going to become
6x squared.
6x squared minus
16y by 1.
16y, and leave that y prime on there that represents y's derivative. And after the equals, make sure you don't leave the 12. I sometimes see that happen on these, that people have a number, they do the derivative, and they leave the number there. And that's not what you want to do. Any number is going to turn into 0. And then your job is to solve for y prime. With 6s and 16s, you're going to get a fraction that'll reduce. Anybody confidence you got 7 fraction?
3x squared over 8y?
It is 3x squared. 3x squared over 8y is a true story. 8, what would the first line look like when you first attack this?
10y y prime
Agreed.
equals 10x to the 4th
Agreed.
plus cosine y prime.
Cosine y, and then a y prime, yes. So the trig word will always have it's called an argument. Just copy the y after cosine, but then we will tack on that y prime. When there's two y primes to algebra solve for, we have to get them all same side. Factor off a GCF if you want to show that step, or we had a shortcut we encountered that you could utilize. Anybody 8 confident in your fraction?
10x to the fourth
Agreed.
over 10y minus the base squared.
Agreed. 10x to the fourth on top, and then 10y minus cosine y on the bottom. That's a win. Those are still 2-point problems, depending on how many mistakes you make. I take half or 1 or 1.5 or 2. Something up to 8. 9's a 4-point question, because to do the first derivative is a comparable skill to what we just did on number 7. And then you have to go some more. Anybody 9 confidence in your first derivative?
Negative 8x over 3y.
That's close.
Negative 4x over 4?
It is negative 4x over 3y. Did you have an 8 and a 6 at first?
Oh, that's what I did.
Did you leave the 3? Okay. You understand 8 and 6?
Yeah.
And then 8 over 6 will reduce the
Yeah.
4.
That was
So
right, just
negative
thought.
4x over 3y is first derivative. Anybody trouble there? Then second derivative, I'm going to take a temporary timeout on that. Did you get first derivative right?
Yes.
Yeah. Did you get first derivative? Yep. Yep. Why don't you try to slightly rework your quotient rule? Did you do a
Well, I
second derivative?
didn't even do the second one.
Okay. Did you try the second derivative?
Yeah.
Yep. You try second derivative? Yep. Yep. What's the bottom when you do the quotient rule?
3.
Square the bottom, so what will it be?
3y squared.
Not 3y squared.
9y squared?
9y squared. You okay with that?
Is 3y in
3y
parentheses?
squared is okay temporarily, but you're gonna have to do that out to attack the top sooner or later. But yeah, the 3y will turn into 9y squared. I'm going to leave that hang for a second. We can double back there. But yeah, try to do the quotient rule before I talk through the quotient rule on that one. 10, anybody 10 confident in their first derivative?
9x squared over 8y.
It is 9x squared over 8y. You hit that one, okay?
Mm-hmm.
You hit that one? Yep. Did you hit that one? Yep. Did you do quotient rule on that, or you're just sort of stalled out?
I'm out.
Okay. Let's go ahead. We'll just skip the final answer on 9 and 10 just so we can verify for that. Anybody 9 confident in your final answer? It's a fraction minus a fraction.
Negative 4 over 3y.
It is negative 4 over 3y. So whether you did or didn't do it, if you want to jot that down as your ultimate goal, feel free. Negative 4 over 3y minus.
4x over 3y squared.
Not quite. Anybody that piece?
4x squared?
Nothing with a 4. Okay, it's going to be 16x squared over 9y cubed. So we will want to work through that one, I think, sooner or later. 10, anybody have a fraction minus a fraction kind of thing on 10 that you feel okay about?
Negative 19x over
No 19. Anybody have anything with a 9?
Something with 9 over 8.
No 8. What's going to happen? Let's try this first. On the bottom, what's going to happen to the 8y?
It's 64y squared.
It is 64y squared. That's the most frequently messed up thing. People relax a little bit too much at the end of their quotient rule. and they don't square the bottom quite right because I think they relax too soon. But the bottom is 64y squared. Well, I'll just read answer. It's going to be 9x on top of 4y minus 81x to the fourth over 64y cubed. That's a 4-pointer because I'll give you 2 points for the first derivative and then I'd give you 2 points for the second derivative, quotient rule of life. 11, you didn't even have to do any calculus. So 11 is a 2-point question. I gave you the tools to just jump in and do some algebra with this. How do you write an equation of a line? How's that usually work?
Y equals,
Eventually we'll get it y equals,
so like
but
y minus.
y
y1,
minus, correct, equals,
the slope.
yeah,
and then
parentheses.
X minus x1.
Agreed. So, based on what I gave you, you'd set that up. Y minus the 5 equals,
5, 7, negative 5, 7,
yeah, parentheses.
x minus 3.
Agreed. And then to get at the final form, I'd like you to distribute that and get the y alone. And we'll just wait a few seconds because I can see people are working on that right now. Then when you write the equation for the normal, you make what one small change?
Negative reciprocal.
Negative reciprocal. So instead of negative 5/7, we'd go with positive 7/5. And we would do the distribute and the y equals, and I'll share those with you in just a moment. Did you get that distributed? Not yet?
Almost.
Okay. You okay at 11?
For one of them, yeah.
Okay.
I'm working on the second one. Right now.
Okay. Once you work out that second one, since you said 12 was the one you skipped, start off doing to 12 what you were doing on like number 7.
Okay.
Same thing, you said you could skip 12.
Yeah.
Do the same thing to start 12 that you were doing back on number 7, the same way we started 9 and 10. Just
Alright.
start that one the same way. You ready, 11?
Yeah.
You ready, 11? The first one on 11, you ready?
Well, which one did you do first?
The negative 5/7 one?
Okay, no, I have the 7/5 one.
Okay. Anybody 11 share the 7/5 answer? Y equals 7/5 x. Plus 4/5 is true? Does anybody need help with the y equals 7/5 x plus the 4/5?
I'm lost.
The 7/5 one?
Yeah.
Okay. Did you have y minus 5 equals?
Yeah.
7/5 distributing x minus 3?
Yeah.
The 7 distributing gets you a negative 20.
Oh, I see what I did.
Okay.
What was the number?
4/5?
Okay.
Did you get a negative 21/5?
Yeah.
And then when you add the 5?
Add the 5. Okay. Yeah. Okay.
Did you get like a 46 or something? If you were subtracting the 5, you'd have gotten like a...
No, I just wasn't doing anything with the 5.
I got you.
So I had the 21.
Okay,
I just
got it. Anybody need any guidance while I'm waiting for the green light to go 11? You working the negative 5/7 one
Yeah.
now? Anybody, we got, anybody 11 confident? The negative 5, y equals negative 5/7 x.
Plus 5 minus 7.
No.
7 and 1/7?
7 and 1/7 would work. 50 over 7 would work. Anybody troubleshooting 11? Okay, so 12 is going to start off the same way 10 started, the same way 9 started, the same way 7 happened totally. We just need to do that implicit differentiation thing and get the y prime solved. So I'll just sort of linger a second while people get to that at point of agreement. This will end up being a 4-point question because there's sort of like 4 steps to it. The first thing is getting that y prime figured out.
Is the y prime negative 3x over 2y?
That's a win. Does anybody need help getting negative 3x over 2y? Okay, then what?
Plug in the 1 and
Plug in the 1 and the 2. And I count that as the second point toward the goal.
negative 3 over 4.
Negative 3 over 4 is true. Anybody need help there? Then basically repeat what we did on 11. Use the negative 3/4 as the slope for the tangent line, but change around the negative 3/4 to its negative reciprocal friend to be the normal line and distribute and whatnot. If anybody gets one of those, just yell it out.
One of them, y equals negative 3 over 4x plus 11/4.
That's a win. The tangent is a win with y equals negative 3/4 x plus 11/4.
This other one, y equals 4 over 3x plus 2/3.
It is. Other win on 12 is y equals 4/3 x plus 2/3. So then what we have lingering is 9, 10, maybe dive into that quotient rule and see where you can get. Why don't you just do that now and we can maybe wrap that up today. Or some other people were on 6 trying to dive through the product rule, but why don't we try to see if anybody can get breakthrough going on 9 and 10 because we shut the room out on those. So maybe everybody 9, check out your quotient rule. Everybody 10, check out your quotient rule. See if we can bring that to a wrap.
First one was negative.
Negative 4x on top, 3y on the bottom.
Okay.
And then 10, we agreed with 9x squared on top,
Yeah.
8y on the bottom. And then we just, everybody got blown up. Do you need to remind a quotient rule how it goes, or you got the mechanics of that?
I'm good.
Okay. if we get everybody, once we get everybody done with the try at 9, let's do a talk through at 9, and then we can hopefully transfer that knowledge up to 10. Let's talk about 9, not wait until people did like 9 and 10. Were you able to troubleshoot, you folks down to my left, were you able to troubleshoot your number 9 to get to the finish line, or are you still stuck somewhere in it?
Yeah, I found out what I had to do.
Were you able to get 9 to the finish line, or are you still stuck? We'll unstick it in a minute. You had a quotient roll attempt?
Yeah.
I did the quotient roll, but I didn't get that answer.
Okay, so let's talk through what we've got on 9 for the quotient roll. So what's the first thing, anybody, that you threw down?
Copy the bottom,
Copy the bottom, so 3y is there, times
negative 4.
-4 from derivative at top, agreed, a minus,
Yeah.
then
Negative 4x.
copy a negative 4x times
3y prime.
3y prime, all on the top. Bottom, we said before, was going to be 9y squared. That's pretty good work.
Okay. Y prime.
Okay, you with that so far?
Yeah.
Did we lose anybody so far on that? It's fine if you have x's and y's. It's not fine to have y primes. So the y prime gets scratched out, and what does y prime get replaced by?
The 4x and 3y.
The original answer that we created that we were doing the quotient rule from, which brings the negative with it again, a negative 4x on top of a 3y. Did you get that far, Nicole, or did we spot it? No. Do you understand how we got there?
No, I did that.
Oh, you did that already. Okay. It's just getting to the finish line from there.
I guess.
Okay. So then what we're trying to do is act like this is two different fractions. In the middle of this, we have a minus minus makes plus moment. So just cover up everything on that top with your thumb so it's like it's not even there. Then just try to deal with the 3y multiplying the negative 4 being on top of a 9y squared, and just like break that thing down.
Negative, wait,
It is negative because of the negative 4.
negative 12y. Wait, what are we trying to get?
You're trying to take that first top, which is negative 12y, but put it over the bottom, 9y squared, and break that fraction down a little bit if you can simplify it.
Negative 4 over 3y.
It is negative 4 over 3y. And that's half of it. That's the half I think we agreed on when we first tried to take this on. Does anybody need help with the negative 4 on top of 3y?
Yeah.
Okay. So
What does this look like?
we have a 3y times a negative 4
Yeah.
minus a negative 4x, 3y, and this used to be a y prime, but it became negative 4x over 3y, all on 9y squared.
Why is it 3y?
Yeah.
Next to the extra fraction.
'Cause it was 3y, but we did the derivative.
Not a
of
y,
that.
I'm sorry.
Okay,
Yeah, that was a y prime, I'm sorry. Good catch. Yeah, that's just a 3, not a y. It was a y prime, and the y prime got replaced. That's a good catch. When I scratched at owl, I scratched out my prime. But no, we're correct now with what's on the book. You with that?
Yeah.
Okay. So now what we're trying to do is act like none of this is there. Just attack that fraction. So the -4 isn't cancelable with anybody, so that's going to be on the top of the answer. The 3 and the 9 are cancelable. The y and the y squared are cancelable, and that's 3y total. That's what the left will make.
Okay.
3 cancels 9,
Yeah.
leaves 3.
Why does that happen?
Anytime you have something like a plus b over c,
Yeah.
you're gonna pretty much always wanna make that a over c plus b over c and try to just break that down. Like here's our,
Yeah, no, yeah.
I'm trying to make the problem be half as hard.
Yeah, no, I
Is it-
understand it.
Okay.
It's just,
Because if I say simplify this as it is, it's like, oh my, that's a monster. But if I cover half of it up with my paper, it's like, oh, I could do that.
yeah,
You with the first piece?
yeah.
Then where we've had issues is on this back piece. So on this back piece, I've got a negative times a negative times another negative. All told, that's a negative. The 4 doesn't cancel the 4. The 4 is like over a 1. This 4 is on the tops of things. 4 is a top, 4 is a top. That's going to be a 16. Similarly, the x is a top, the x is a top, a couple of tops with x's, that's an x squared. This 3 kills that 3 though, because this 3 is like it's over 1, that's a bottom kind of 3, so 3 cancels 3s, the 3s are dead. The 9 is still stuck there, so we get a 9 still on the bottom. And this y squared is underneath the other y. All those y's are like under things. That's a grand total of underneath y, so y cubes.
So that's the answer.
And that's the answer.
Okay.
Did that help you to victory?
I'm pretty sure I did everything right, I just didn't separate the fractions.
Okay.
And then I didn't know how or why you were doing that.
Yeah, like if I say simplify this, it's like, oh my, I don't even know how to do that. But if you break it into 2 chunks, it's like attackable.
Yeah, I just simplified it the way it was.
Okay.
I just multiplied everything on the top, put the 3 down at the bottom, and had it like it's 1 fraction over 27.
Maybe you could do that. If you shove this 3 to the bottom, you'd have to multiply this by 3 to pay for that.
Okay, then I just did it wrong.
Like if this is one single unit and you attack these, you can't like leave that out too, because you multiplied this by 3 to kill it. That multiplied this by 3 to 27, but you didn't touch that, so that went a little bit out of whack. Safest way
Yeah,
is the separate.
yeah, I can do it like that.
10 will flow about the same. I don't think we have time to finish 10 now, but try to see if you can get 10 to the finish line. We can talk about that tomorrow. 6, we would need to try to do a product rule. We could get that going tomorrow. New sheet, I'll give you now. It's going to have the same style questions in the same order, and hopefully it like goes a bit better. Seems like other than 6, 9, 10, we're okay-ish. Does that seem true for you? 6, 9, 10 is trouble, the rest seem doable. Is that where you are? Yeah, about the same for you. Anything bother you other than 6, 9, or 10? No. The basic skills are there. We fine-tuned a little bit of the details with another sheet. Shut that down. Okay, So here's the details on 6 after a small delay into the next day. In case people think I did a wardrobe change during this video like Beyonce or something, I did not. This is a new day. But 6, we need to do our good friend the product rule, which makes us copy the
First.
first times
The derivative.
derivative of the second, which is
2x.
2x plus, then copy the second times derivative of the first, which has a fourth power. We'll have to do the chain rule. How are we going to do derivative of that fourth power? Four stuff cubed, and then also in the mix, the derivative from inside the parentheses.
3x squared plus 10x.
Agreed. And that's a good strong first move. Question about that.
So take 1 out of
So,
the.
magic trick from the homework is that these almost match, but not quite. So I should have probably left myself a little bit more space there, but we're gonna keep 3 of them as a group and then bring out an extra one. So when we go to make answer, who is unavoidably in this answer? The cube version of that. So the parentheses that I put in the boxes, the cube version of this, cube version of that, we got a cube version in the answer, that's just part of this. To get the other part, we have some algebra to do. Here we have to distribute, which is 2x fifth plus, what,
2x.
this was?
Like, why is it?
Oh, yeah, you're right. Because you're right and I'm wrong. Good to have you here.
10x.
10x cubed. Good. I was just making sure you're paying attention. That wasn't.
Sure,
I
sure.
messed it up. I'll freely admit that. You caught me. This will be
12x to the 4.
12x to the 4
40x to the 3rd.
and 40x to the 3rd. I'm very confident I would have caught myself. How at this level would I probably catch myself if I had?
Because they don't.
Because they don't quite like fit, and they don't have to fit. There is the possibility that they won't fit perfectly, but if they don't, I'd be inquisitive and I'd go back and double check. But this will make us get
14x to the 4 plus 50x to the 3rd.
agreed. Question about the magic of number 6. Let's do the magic of number 9. Yesterday, number 9, we agreed on this as a first derivative. And then things kind of went off the rails for us when we tried to work on that. So quotient rule, we copy the bottom times derivative top minus top times, which is 3 y prime, which that's got to go. Question before I get to go. What replaces that?
The negative 4x.
The first derivative that I already showed up on the board. So negative 4x over 3y. Bottom,
9y squared.
9y squared. Did I do this one yesterday? All the way or no? I don't remember either. I thought I didn't, but now I'm doing it and I feel like I did.
You definitely started it.
Okay. We'll finish it. So I definitely remember picking up my paper and covering pieces of it, and you were giving me the annoyed face at some point.
I was ready to cry.
You were. You didn't though. You held it back.
For today,
Choked back those soft tears.
we didn't go
Like
back
in
to
the-
back days.
Like Ryan Reynolds in The Proposal. Choked back his soft tears. So, first fraction, who can cancel who?
The 3y, or it'd be negative 12y
We could multiply that, or we could cancel it first, it doesn't matter.
to the 3y.
3 and 9 could cancel, and that would leave me,
3 on both.
3 on the bottom, I could do that. Who else can cancel?
The Y's.
Y's, leaving me,
Y.
Y on the bottom. And then I didn't
-4.
touch -4, I could leave that on the top. Over here, minus, minus, and minus.
So minus.
Is gonna leave us a minus. What's gonna happen with x's?
16x squared.
16 for that number,
X
x
squared.
squared, that's all on top. Canceling, 3 can do 3,
So 9y cubed.
9y cubed. Call that a victory. Make sure that agrees with my paper, and it does. I celebrate. Yay. Something about 9? I know I did not do 10. Something to highlight that I've seen go wrong, like a lot of times, is the 3 had to get squared to make a 9. That is the downfall of a lot of people. 10, I think we agreed on 9x squared over 8y. And
Yeah.
then we like bailed out.
Yep.
So we take the
Top. Top is
Top of the
bottom.
Top,
Sorry.
bottom.
Top of the bottom.
times derivative of top, which is
18x.
18x minus
Copy the top.
top 9x squared times
8y prime.
8y prime, which goes in place of 9x squared over 8y. All on top.
64y squared.
64 is probably the key, and then y squared. Something about that.
8s can cancel.
8 with 64
So that's
leaves.
8 on the bottom.
8 on the bottom. But if
Y.
we leave 18 on the top, that's not quite perfect.
It's
but
9 over 4.
It's 9 over 4 as best answer.
And then y's can cancel.
To
So y on the
leave
bottom.
a y,
And then x on
and
the
there's a stray x on the top, and we're halfway home with that. Something there. In this world, easy cancel. I'd say that 8s is a nice cancel. 9s,
81.
81 on top,
X to the 4th.
x4 on top,
And then 64
64
y.
on
cubed.
bottom, and a y cubed, because one of those and 2 of those together make that. And there's a total victory.
I understand.
If you can do 10, 9, 6, you're good. Because all the rest of that stuff is significantly easier than 10, 9, or 6.
It's in there.
We're getting there. We seem to have an increase of our confidence now. That's a wrap.